Yesterday, under geometry of straight lines, okay, I did a recap of adjacent angles on a straight line, vertically opposite angles, angles around the point, and then I moved on to corresponding angles. So today I'm going to carry on to alternate angles. Now, your alternate angles are angles that are found on different sides of the transversal, okay? But they will be inside two parallel lines. So here, let me just zoom this. Right, so like in this diagram here, we have got line AB, which is parallel to CD. Then we have our transversal EF or FE, okay? Now this angle G1 is going to be equal to H1. And we call those angles alternate angles, okay? Now as you can see, the two angles, H1 is on the right-hand side of the transversal, G1 is on the left-hand side of the transversal. But both angles are inside parallel lines. Okay. Also, if you try to draw a Z, you can draw a Z. Okay. And here too, we have got that shape there. Because G1 is equal to H1. Also there. But generally, as teachers, we just generalize it as an N. Okay? We just generalize it as an N. So, yesterday I spoke about the F. Okay, now I've spoken about the N. So the F is for corresponding, the N is for alternate angles. Now I need to move on to co-interior angles. Okay, so always remember that alternate angles are equal. Okay, alternate angles are equal. So when you write the reason for alternate angles, you just write alt, and you put that angle, then you name the lines that are parallel. Always. You have to name the lines that are parallel. So this is how you write the reason. To specify that they are alternate angles, please, you don't write alternate angles equal. Okay? You don't write alternate angles equal. Please. Okay? You won't write alternate angles equal if you are asked to prove that two lines are parallel. Okay? Here, you just write alternate angles and you specify the two lines that are parallel. All right? Any questions there? Okay, this is recap of grade 89. Right? Then we have got another type of angles. Okay, co-interior angles. Now, co-interior angles are supplementary, which means they add up to 180 degrees. Okay? So, for you to be able to identify co-interior angles, you must have a set of lines that are parallel. Like in this case here, AB is parallel to CD. So, angle G1 plus angle H1, they give you 180 degrees. Right? Both angles are on the same side of the transversal, and they are between the two lines that are parallel. Okay, co-interior angles are supplementary, which means they add up to 180 degrees. So when you write the reason for co-interior angles, your reason will be co-int angles, then you name the lines that are parallel. Like in this case here, it will be G1 plus H1 equals 180 degrees. Your reason will be co-interior angles, and then you state that AB is parallel to CD. Okay? So whenever you identify corresponding angles, co-interior angles, alternate angles, you must specify the lines that are parallel. every time. If you don't specify the lines that are parallel, then you might not get full marks for that reason. Is that clear to everyone? You have to get used to it now in grade 10 because geometry is a major part of your curriculum. Okay? It's taught in all the grades up to metric. And when you write metric, it's a major topic. It has got lots of marks. So if you have a solid foundation from grade 10, you're going to find that as you get to metric, things are going to become a little bit easier for you. All right, so I'm done with geometry of straight lines then. Now, the next aspect, which you have done as well, is geometry of triangles. Okay, so with the triangles, we'll just start with an acute angle triangle. Now, an acute angle triangle is a triangle that has got no angle which is more than 90 degrees. Okay, it means all the angles are between 0 degrees and 90 degrees. Okay, so that's what we have. Okay, we call it an acute angle triangle because no angle is more than 90 degrees. Okay, then we also have a right angle triangle. Okay, now for the right angle triangle, obviously we have one angle which is equal to 90 degrees, and that angle will be opposite a side which is called the hypotenuse, which is the longest side of any right angle triangle. Now, the moment you've got a right angle triangle like here, then the theorem of Pythagoras kicks in. The theorem of Pythagoras is only applicable to right angled triangles. If the triangle is not right angled, then you can't have the theorem of Pythagoras. So, the 90-degree angle, this one here, is always opposite the longest side. And that longest side of the right angle triangle is called the hypotenuse. So we end up having theorem of Pythagoras. Now, theorem of Pythagoras is very, very important in mathematics, also in sciences as well, like physics, okay? But it's very important up to metric. It has got many applications in other topics, which we shall see later on. All right? So make sure you know that when it comes to your triangles, with the acute angle triangle, no angle is more than 90. With your right angle triangle, your right angle triangle, which means that there's one interior angle which is about 90 degrees, and the side opposite that 90-degree angle is the longest side, and it is called the hypotenuse. Okay, so from your theorem of Pythagoras, obviously, the first equation here, that's the theorem of Pythagoras. Okay, who can tell us the full statement of the theorem of Pythagoras? What does it say? Not as an equation, as a statement. What does it say? Let's say you were to go to a mall, and then you get to the entrance. Maybe you are picked up, and then someone from the shop says, okay, we have got some nice goodies here. Can you tell us what does the theorem of Pythagoras say? What are you going to do? Are you going to choose to not get the goodies, or you have to give the correct answer? If you have to give the correct answer, what would you say? Yes, right.
The size of the hypotenuse is equal to the same size as the two sides squared.
No. Yes, Ari.
The hypotenuse is equal to the two other sides of the triangle. I don't know.
Okay. Be very careful, especially the second part of the other two sides. Be very careful how you say it. You know that is not what you say, but how you say it. Okay, according to the theorem of Pythagoras, okay, the square of the hypotenuse, okay, is equal to the sum of the squares of the other two sides. Okay, the square of the hypotenuse, in this case AB squared, is equal to the sum of the squares of the other two sides. So you have to square AC square BC, then you add that sum. So when you say be very careful, because from my experience, for some of you, the way you say it is more like you are adding AC plus BC, then you square that. No, you are adding the squares of the other two sides. Then you should get the square of the hypotenuse. Okay? Don't worry, we'll come back to the theorem of Pythagoras later on. Right? Okay, so we've got that. Then we also have an obtuse angle triangle. Now, by obtuse angle triangle, we are saying one of the three interior angles is now more than 90 degrees, but less than 180. Remember, your obtuse angles are more than 90, but less than 180 degrees. So an obtuse angle triangle has got one interior angle which is more than 90 degrees, but less than 180 degrees. So you have got that. Okay? Then we have got a scalene triangle which has got three sides, obviously, that are not equal. Okay? So you've got your scalene triangle there. Now you were taught this in the past. Then you've got your famous isosceles triangle, which has got two sides that are equal. Okay? It has got two sides that are equal. It also has two interior angles that are equal. Okay? That's a unique property of an isosceles triangle. But when you, I'm going to talk about that more. Isosceles, that's where I am now. Okay? Isosceles. Now, with regard to the isosceles triangle, you are going to encounter it a lot in grade 10, grade 11, grade 12. So, when you want to prove that two sides are equal for an isosceles triangle, please, you don't give your reason as isosceles triangle. Also, you want to prove that two angles are equal, you don't give your reason as isosceles triangle. In the case of two sides being equal, and you are given that the angles opposite those two sides are equal, your reason would be sides opposite equal angles. Please take note of it. You don't write isosceles triangle. Okay? If you were taught that in grade 8 and 9, that should stop from now on. That should stop from now on. No more reason like isosceles triangle. No more. Is that clear to everybody? Yeah. So if you get an isosceles triangle like this, and you are given sides such that they are opposite equal angles, if you want to prove that the sides are equal, your reason will be sides opposite equal angles. I'm saying this many times because it does happen. Is there anybody who was taught that way? Huh? No more isosceles triangle. Then, if you want to prove that two angles are equal, because the sides opposite those angles are equal, your reason will be angles opposite equal sides. Okay? Please take note of these two. The first one is for proving that two sides are equal. The second one, proving that two angles are equal. Obviously, the triangle will be isosceles, but when you give your reason, it's not isosceles triangle. Okay? And among these types of triangles, the most important is the isosceles, because you are going to encounter it a lot in questions. When you are answering questions, you are going to encounter the isosceles triangle a lot. Right? Then we've got an equilateral triangle, which has got three interior angles that are each equal to 60 degrees. That's the equilateral triangle. Okay? Your equilateral triangle has got three angles that are each equal to 60 degrees. Alright? And then the last property or the last concept on triangles is the property of triangles, which is called the exterior angle of a triangle theorem. Okay? Exterior angle of a triangle theorem. So if you draw a triangle ABC such that you produce C to D, okay? You produce C to D in order to create two angles at C, that is C1 and C2. Those two angles, C1 and C2, will be adjacent angles on a straight line. Therefore, if you do the math, A plus B plus C2 gives you 108 degrees. That's sum of angles of a triangle. Right? Then, if you add C1 plus C2, you get 180 because they are adjacent angles on a straight line. Okay, let me just show you this. So someone might be saying, what is he saying? Right? If you add A plus B plus C2, you get 180 degrees. Okay? The reason is that they are sum of angles of a triangle. Then, if you add C2 plus C1, you get 180 degrees as well. Do you see that? Huh? Then, now, if, okay, you've got two equations here now, right? The right-hand side is the same. Do you see that? You too. Can you pay attention? The right-hand side is the same. So we can equate the left-hand side and write it as C2 plus C1 is equal to A plus B plus C2. Do you see that we have got C2 on both sides? Huh? So if I take a C2 on either side or to either side, the C2 disappears. So this C2 and that one cancels. You will left with C1 being equal to angle A plus angle B. Okay, so this angle here, C1, is equal to angle A plus angle B. And this theorem is very, very important. Okay? It's called the exterior angle of a triangle theorem. Or you can just call it a property of triangle based on the exterior angle. It's very, very important. You encounter it quite a lot, and some questions they can easily be done using that theorem. Yes.
So, sir, if C2 had died, could we not use angles on a straight line?
What?
If C2 had died, could we not use angles on a straight line?
Okay, the objective of that property of theorem is for you to know that the exterior angle of the triangle is equivalent to the sum of the other two angles. That's the objective. Alright? It's not to calculate a specific value for C2. Okay? So for any triangle, the exterior angle of the triangle is always equal to the sum of the other two angles. For any triangle. Okay? As long as we've got an exterior angle, then it's equivalent to the sum of the other two. Right? Don't worry about this. Later, when I start doing examples, we will do a question where you need to apply that. Okay? Alright. Any question? Any question? You see, all these concepts, you're supposed to know them before you start doing geometry. You have to know everything that I'm doing now. Okay? And that will make your life very easy for the topic. Okay? And I want to emphasize this. In my class, can you be silent? In my class, geometry is very easy. Know your basics. Know your geometry concepts. You will be okay. Okay? I don't want to hear anybody say geometry is difficult. I don't want to hear that. And don't surround yourself with people who tell you that geometry is difficult. Okay? You need to have a positive attitude. Also, you need to make sure you know your concepts on geometry. All right. Okay, congruency. Now, what do you know about the word congruent? What does the word congruent mean? What does the word congruent mean? Remember, you did geometry from grade 8? Huh?
We were never taught congruencies and similar. They left it out. We weren't even tested on it, so we weren't taught it. It was just skipped and the triangles.
Last week or six?
Yeah, we went to it. We haven't done it.
I was not aware of that. So you've never done this? What about grade 8?
Just grade 7. We didn't do this I haven't said that.
Serious?
Yes, we already forgot similarities. It was left out of our papers.
Were you taught?
No, it's words.
But I'm going to change that this year. Unfortunately, can I have your attention? Okay. Okay. Because I think I told you yesterday because I wasn't aware of it. Right? So, for those who are doing grade 9 this year, they have to do their geometry. Those who are doing grade 8 this year, they have to do their geometry. They have to do. Okay? I wasn't aware because I'm not teaching grade 8 and grade 9. But I'm the custodian of the maths department, so I wasn't aware of it. Yes.
We did geometry.
So, but you never did any proofs and all that. So, which means, okay. So, what exactly? Can someone just tell me what you did? Was that information is very important? Yes.
So what we did was that we did. So everything we got over now in this lesson, sir.
Yeah.
That was basically all to do with triangles in our paper. We had Pythagoras and then
Quadrilaterals.
and we had quadrilaterals.
Yes.
But when they said triangles in the breakdown, it excluded congruencies and similarities. So it's just Pythagoras and properties of the triangle.
Also, okay. So you're saying in terms of assessment, it wasn't put in assessment. But did you learn it in?
No. We were never
So congruency was not taught. Similarity was not taught. In grade 8 as well. All right, shame. I'm sorry for you for that. Okay, but well, at least things are starting to get better now. Okay, so what I'm just gonna say is that it means you probably have some gaps because of what transpired last year. But I'm gonna try and make sure that the gap is as narrow as possible. Okay, because this topic it's very, very important. When you write metric, just to provide you some information, this is important for you to know. Now, there are two papers in metric, right? Paper 1 and paper 2. Paper 2, that's where you are tested on geometry. In geometry, out of 150, the paper out of 150, yes, about 40 marks out of 150, it will be geometry. Therefore, there is no way that the topic cannot be taken seriously. There is no way. Right? So I'm very grateful that because we are going over this, you told me about that. I'm meeting the teachers today at first break. I'm going to tell that the grade 8 and 9, they have to teach this so that we don't have problems later on. All right, let's get on. So it means that this year will be your first time to be assessed on congruency. Now, unfortunately, similarity is not a major part of grade 10, but it comes in metric now. So if you were not taught similarity, you're not assessed properly in grade 8 and 9, it means you are going to see similarity more for the first time in grade 12, which is which is going to be a disadvantage. Anyway, I'll try my best. So let's start with congruence now. The word congruent means similar in all respects, okay? Or you can say the same in all respects. So when it comes to triangles, okay, we mainly focus on congruent triangles. By congruent triangles, we are saying their corresponding angles are equal. The corresponding sides are also equal.